yet. So I'm going to skip ahead a little bit and do half of a presentation now, and I'll do the other half after lunch. And what I want to kind of work to talk to you guys about is some of our research program highlights. And so this morning now you've kind of heard, we've talked about surface water, we've talked about groundwater, and now I want to just be sure that you guys know what we're actually doing to help bring you guys better practices, better responses, better timing or manure application rate, whatever it is, or the things you're already doing so that you can maximize that. And I have to give kudos, and everyone kind of has to date, to say that, whether I'd like to think it's this training all to itself, but you guys are getting better, period. And you're more aware of what's going on. Everything we've talked about today, you now know more to make better decisions, to be more informed, to ask better questions, to start learning other things that you need to know now that you're aware of groundwater or surface water, whatever's currently going on. But looking at these positive trends is fantastic. I know there's a lot of discouragement that happens when dairy in particular, being a large, easy target, if you will, is always getting nailed for what's happening out there. And oh, it's the dairies, are the ones that have manure. Well, I'd like to say that seeing all these positive trends, I hope you guys can take a little breath there, to feel a little pride, to encourage and congratulate yourself and your neighbors as well for a positive trend and things that are going. And I want you to keep it up. It's not the time to stop. It's the time to keep going, to keep perfecting that, to help others who may not be to the same caliber or level, whatever you can do. So I am really impressed. And to see the data, I see it when I look at what you guys are doing, when I visit with the farmers, but to see it in the data is really where it's showing up, and that's important. So I just want to take a moment to have kudos for you guys all. And so I want to share with you some of the things that we're doing at Whatcom Conservation District to bring you guys better practices, to understand things a little bit better. Just because we say, you need to do this practice or install cover crops or put a riparian buffer, that's pretty generic. We want to figure out, how do we do that? Well, let's discover new practices. Sometimes I'll see a farmer doing something, I'm like, that is a great idea. Let's put some proof behind that to see how it works, to be able to say, yes, this is a good practice, and we're going to carry it forward. And so I want to first talk about our Washington Discovery Farms program. And this is a program specifically where we are looking at conservation practices and the effectiveness of that. And we want to specifically, this program is looking at it from a surface water standpoint. We want to see how well are these practices protecting surface water and how well are things looking. And so this program, we actually adapted from Wisconsin and a few other states back east. This is the first Discovery Farms-based program here in the West. And the point is to understand or increase our understanding of the effectiveness of those land conservation practices, to provide a strong education and outreach program. That's huge. So this program in other states that we're adapting here is kind of led by farmers. So it's you guys saying, this is the stuff we want to know, and then this program goes out and gets the funding to answer those questions for you. So it's instead of regulatory agencies or universities or others just saying, hey, this looks cool, let's figure that out. It's you guys saying, how will the setbacks work? When should I be putting my manure application out there? So on and so forth. Those are the questions that we're asking, because those are the questions that you have. And really does not only provide this information back to you, but to policymakers, such like the CAFO permit that came out, the 100-foot setback. I fought very hard in there to say an alternative should be our seasonal manure application setback distances, because they work. Here's the science behind that. We are now currently testing those on fields, on farm fields, to show here's the real proof. Here's that data and that science to show this works when done this way, so that you have alternatives that allow for better farming, for better use of your land, and in the end, you have a better crop, everything is looking a lot better. So informing policy folks is very important as one of the outcomes. You are the first clientele of the receipt of that research. You're the demographic, but getting it to those people is just as important, because it benefits you twice over in the end. And of course, looking practical, economic, and effective aspects of all practices that we look at. I'm not going to tell you like, hey, this works really good. Oh, it's going to cost you about $1 million. good luck with that. You know, there's no way that would work if it's not something that's going to have a really big benefit back to you and have a lot other benefits on your farm and your practices. So as I mentioned, what we're doing is called edge of field monitoring. So we pick a drainage system on a field where we know water is running to. We know that there's a known acreage, 5 acres, 10 acres, whatever it is above that. And the water kind of channels through into something, this is called a flume. And we've got a big box full of equipment that then samples that water when we have a runoff event. And in here, we are looking at all sorts of stuff, but nutrients, so nitrogen and phosphorus, sediments, pathogens, that runoff flow and volume, the weather, soil moisture and temperature. These last few things are really important for us to say, okay, when your soil moisture meets X and we get this much rain, you're most likely going to have a runoff event on this type of soil. So it really helps us really perfect and improve that manure spreading advisory that we've got for you to get it finer and finer tuned for your specific area and your specific fields, so we can really dial that down. That manure text alert, for instance, will get better and better the more information that we know based on this, because we can have better predictors out there. So it'll just really help you guys. And there's a uniform setup across farms. That means that you can have confidence in the data that comes out, and that all the farms that we're looking at all have the same setup so we can compare. And in fact, we can compare all our data to Wisconsin's data. So we can use what they found, and when our soil types are similar, we can use their data to share back with you. So there's a lot of value in having this really big collaborative approach with other areas and other farms and other states that really benefits everybody. Makes our money go a lot further as well when we look at those things. Another really big part of this is data and data sharing and data confidentiality and how that works. I know everyone's very conscious about that these days, right? Like, I don't want anything off my farm, I don't want to get in trouble, or so on and so forth. That to me is one of the biggest concerns and considerations I work on. And number one, there is no bad data. If we get, let's say we get data that's high in nutrients or fecal calls or whatever it is, all we discovered is a methodology that is not successful in protecting resources. That is just as important as me finding the one that does. So I can say, don't do these things, do these things. So there is no bad data. There's only data that shows us the way we shouldn't be doing things under a specific circumstance. The data it focuses very much on you, on landowners, and with the way that this program is set up currently, a lot of our edge of field funding is coming through the NRCS EQIP program. And so there's a big boom there. The positive there is that the data is confidentiality protected. However, today you're going to see I'm going to share some of that data, because we pool it, we scrub it of who it is and how it is and all those pieces, so that there is an agreement that landowners say, please keep my confidentiality, but yes, share my data with my other farmers so that we can all benefit from what we're doing. There's no point doing research in a vacuum just for one person if I know it can benefit others and you can't receive that. So it's very valuable to do those both and share in a productive way with everybody. And so that's what I kind of want to show you today. So over the last 2 years, we've been establishing these edge of field sites. And we've got one that's been in for almost 2 years, and 3 that we've just gotten in this last season. So we've got a little bit, and we were trying to get across a wide variety of soil types. And so we've got 3 primary soil types that fall within these categories. To me, that's really important because, as I mentioned earlier when we talked about nitrate or anything else, what we find is that your manure application strategy is very specific to your soil. Your timing is very specific to your soil. We have to start thinking that way. You guys do it intuitively by saying, well, I know I can't get out on that field, but I know I can get it on this one. That's because your soil type, most likely, and what's happening out there. So I just want to put a little science behind that for you, so that when we give you your nutrient management guidance and your plan, or your any kind of crop, it could be a berry farm, anything else, when we start planning by soil type, it gives you a lot more information and adaptability to all your fields, anywhere, wherever you end up. Or if you're a manure applicator, or you are a technical support person, by knowing how things work on a soil type, you can adapt that information to any farm, anywhere. So it's just a little bit easier way to start thinking. I like to think of it, we kind of have our sandy soils, our silty soils, and kind of our clay muck soils. So kind of those three broad categories, just to think of it that way. And what we found, and this is just a little bit of data that we've got from 2016 to 2017, October through, kind of that March, April time is about like a water year is what we'll call that, right? So that's our big rainy season before, what is it usually, June, well, June it can keep raining on us, but usually around there it starts to click off. And these three graphs, I just want to show you a little comparison here. This top one in orange, this is rainfall, inches per month, starting in October through September. And then this one, the blue, is runoff events per month on one of our test fields, one of the plots, October through September again. And then the gray is the runoff in gallons per month. And you can think of like, what was the severity of that runoff event, again, in the same month, same scale. So when you look at all these together, you don't even have to look at the numbers over here, but just look at what those look like. In the orange one first, this is pretty typical, right? We get a lot of rain October, November. It does seem to decrease December, January, and then we get that big spring hit somewhere in March, April time period, right? You all kind of know this. This is our approximate normal weather pattern. Well, not too surprising, our runoff per month kind of follows that exact same category, right? The difference here is that the first one is going to be dependent on your soil type. So in other words, your soil has to saturate before it starts running off. So it'll take in all of that rain and all that moisture until it's reached its critical tipping point, and then it's going to start going. And so this time, this October period is going to be reached quicker. For like a clay soil or a really silty soil, it's going to take a little bit longer for a sandy soil to reach that. And somewhat a peat soil, right, that can take up a ton of water, as you know, and then boom, it's saturated, and it's going to start running off. And that's why you see the volume of those runoff events isn't so big in October, but come November, that's when you know your soils are pretty much saturated. You get inches and inches in that October time period, and then come November, it's going to really start running off. And that's a really valuable thing. Without even the details behind it, the concept is important for you. And frankly, I think it validates something we already know, is that when do we have to really worry about our runoff time, and that's it. So however long you decide to gamble on going out in the year for putting manure out on your field really depends on your soil type. And it really depends on what's going to happen, and are you going to have that runoff event, and how severe is that going to be in your area. And then come this spring is the same. When do we get manure out on those first applications? Is your soil still saturated, and how's that going? So I always talk about that soil saturation perspective with you guys, and the soil moisture percentage in your field as one of your biggest factors for should I get out on my field or not. And so that's a really big, important one to consider. And so I want to do this slide, and then we're gonna we'll break for lunch, and I'll come back and talk about our other program as well. But this is kind of the same idea I just showed you, just a little bit different way to see it. And on this graph, what you see is that the blue dots, or every dot, is a rainfall event. And the ones that have yellow were the ones that were also correlated with a runoff event. So you can see early on we can get big rain, but not quite that runoff yet. And then once it hits saturation, it's more, and then we kind of flip the other way when things start drying out later in the year. So again, this is starting in October and going throughout the year. And what we found is that once soil hits about 80% saturation or greater, in that upper 6 inches, that's when it starts running off. And it can only take 0.16 inches to start a runoff event once you've hit saturation. Later in the year, it takes a little bit more in this time period where you're saturated and unsaturated. So it's just, your soil's wet, but it's starting to take up that. You've got crop growing, things are a little bit better. So it takes a little bit more, but it can only take a 1/4 inch to cause a runoff event. So and this is in a little bit heavier soil type. This is more like your peat muck soil, so worst case scenario you can think. But it doesn't take very much as we move throughout the year. And same here that we're looking at, this is just one schematic of a runoff event. So this is the kind of data we get. Don't worry about really trying to understand this. Just know that a runoff event, this is our precipitation down here. So you can get a little bit of rain, and then it's a lot, and it kind of chills out for an hour, and it comes back. This is very typical of how we get a, quote, rain event here. And then the runoff, you'll see there's always a little bit of delay right behind the big peaks, but once it starts, it goes for a while, and then it just slowly tapers off. So understanding that too, how does a runoff event work? It doesn't just kind of like run and go. It like starts to run off, and then it slowly tapers out. So even though our rain event has stopped, it may take a day or 2 days before your field has stopped running off and is now getting back to, okay, I'm going to start waiting for that rain to not come back for a while and let all that water all get into my soil so I don't have a saturation. So it's interesting for us, and we'll keep presenting as we understand more. This is our first year of data, so we're really trying to bite through this and understand it. But it does take a while. It can be 8 hours or more when that's running off afterwards. So if you're going to do water sampling on your own field, if you're curious, this is good for you to know that the rain event is stopped. It's still going to run off for a little while if your field was running off. And it gives you an idea of how to sample on your own field if you want to do some self-validation work there. And to know too, just without going too much into the data itself on the lab results, that in October, November is when we get the greatest counts of everything. Not surprising. There's manure is applied September into October, so we have the potential for the greatest, and then it's much less, obviously, in those middle of the year. And this is also valuable for us to know this, is that, yeah, when there's manure out there, it's obvious that it has the potential to go somewhere, and then not so much. So if we're getting high counts in December, January, we're feeling pretty confident it's probably not from this type of an event, a manure application runoff from a field. So this is valuable as well, that we're going to collect more data to understand this. This is very preliminary data for just an example purpose, but it really is kind of getting somewhere there. So, essentially, for our 3 soil types, for our peat muck soil type, the first runoff event happened around October 18th. It was a little bit later for silt and even later for sandy soils. We were into November, and it just shows you that on those heavier soils, the event duration is moderate and it's medium in size. And the silty soil, it's going to be a longer duration, a bigger runoff potential because of the way that soil type works. And in sandy soils, short duration, short runoff event. So this is even interesting, and we're going to digest that information a little bit more to better understand it as well. But that's kind of how things are shaking out so far. And that's good. Again, this helps us give even more information on a soil type specific level and basis so that you can start better understanding that. We can start giving you better information on it. So I'm going to hit a pause, and I'll do the rest of this presentation in our next half. But are there any questions just on that part that I presented? You can always catch me at lunch too.
Cool.
Okay, yes?
How many EOS do you have? How many EOF sites?
We have 4 sites.
4 sites.
Yeah, so we have 4 farms, and on each farm we have 2 of these edge of field monitors so that we have a control and a treatment. So we can look at, let's say, different setback distances or timings and have 2 different comparisons so we can say, is there a difference or not? Yeah.
And then how are those samples taken? Is that a ZAP type of sampling, or do you have to physically go out there and pull samples?
So we have an automated sampler out on all those sites so that when there's water comes through the flume, it's triggered and it starts taking a sample based on however we want to do that. We want to take 100 milliliters per hour, or we want to take all the volume, however it goes. Sometimes in the very first runoff events of the year, what we've done is we take a sample every hour because I want to know how does the concentration change on those first runoff events. And of course, no surprise, we get a lot of, let's say, nutrient, and then it tapers off. Or we just get the whole event at once. So we have options. And then someone has to go out and collect that sample within 24 hours to get it to the lab. So it is kind of a combo of both automated and, we have staff that goes out and takes those. Yeah. Any other questions on this? Okay, I'm going to finish up my presentation I started before lunch, and then we're going to have Kent Oostra come talk about DNA methods, etc. So I want to now move, so I talked to you about our edge of field monitoring program and how we're bringing you better results for your practices and how to implement those more effectively to get the water quality results that you want to see. And this project now is a collaborative project that the Conservation District is doing the technical part of it. So we are doing the installation of what are called ZAPS, real-time water quality monitoring machines. And these are essentially these big silver boxes that, frankly, it has an algorithm to it, it has all sorts of fancy stuff. There's lights involved and so on and so forth. Without going into the technical bits of how they work, what they provide is real-time E. coli measurement, nutrients including nitrate, nitrite, total suspended solids, biological oxygen demand, and hydrocarbons. And what we're really interested in here is this E. coli measurement. And so we are part of a project that is a very large group of folks, EPA, Department of Health, Department of Ecology, Department of Ag, the Lundy's, Whatcom County, the ZAPS itself, and then us doing the technical implementation of that. We're part of a group that's looking at these water quality monitors. I mean, real-time water quality results is pretty great, right? It gives us a real nice sense of better understanding what are the daily, seasonal, annual kind of trends in water quality changes. How about by location and parameters? Different water courses have very different signatures associated with them and how that comes across. And so the goal of this project is not only to see if these things actually work, so that unto itself is a project, but also just to get a better sense of water quality. And this, there will be 5 units deployed in the watershed. There's already 3. We're in the process of getting 3 more in, or 2 more. There's already 1 through a different project that's in, so 6 total in Whatcom County through 2019. And you can see about where these are. There's already 1 down in the Nooksack. We've got a couple within kind of the fish trap area that are in the Linden zone. We're getting 1 at the border installed right about now, very soon, which is great because I think that's the question people have more than anything. What is coming across the border? When is that coming across? As it is right now, that kind of routine sampling is on a monthly or bi-monthly basis. So you just get a snapshot, a 1 moment, 1 day. This will give us what's happening all day, every day, kind of an idea. And frankly, there's still a lot of validation that needs to go with it, but it's going to start giving us some interesting information and some good data. So 2 on the Nooksack at Linden and Ferndale, 1 on the fish trap in Linden. That Canadian border is going in, and then we're working on the other 2 kind of near the end of Bertrand, and then potentially another at the mouth of the Fish Trap Creek. This last one will be a mobile unit, so we'll be able to move it around and look at different places as kind of it arises and curiosity arises a little bit. So those locations are dependent on the cost, of course, and property owner cooperation. You can we've been very lucky in the places we've been able to install this, but you can understand, I'm sure each one of you, the hesitation of having one of these units located at your property, even though it doesn't matter. We don't really care where it's located or what's adjacent to it, just the water itself and everything that's upstream of that and downstream when we get to another unit. So really this is just, you can tell we're not bracketing anything or anything else. We're just kind of throwing these in all different water bodies, sizes, like the Nooksack versus Fish Trap versus the border versus Bertrand. They're all significantly different watersheds and water bodies. And we want to look, what does sediment load do to these things? And what does temperature changes or different levels of potential nitrogen values in there? So we're hoping it's going to give some interesting information as it goes across. So these trends and diurnal cycles, you can see this is just a snapshot of what that data would provide. And the blue is E. coli. The green is the nitrate, nitrite, so that nitrogen value. And the pink here is a total suspended solids. So you can see that solids and E. coli, things are just humming along, and then you can get an event. And it was inverse of nitrogen. Why? We don't know that. So we have a lot of questions that are coming up with this that we're going to start to better understand water and how it comes across and what it's doing and how it changes. And so this event, for instance, what was that? Was that a big sediment load that came across? Was there a discharge event somewhere? Was it septic? Was it wastewater treatment plant? Was it agricultural? Was it otherwise? So a lot of different questions that are coming up with this that we're trying to better understand. And it's really nice we can, to some degree, a real-time examination of water quality and practices by looking at this on a positive note. To say if we did have one of these in and it always read kind of high, let's say. If everyone in a watershed did a positive implementation of a practice, would we be able to see that reflected immediately or a little bit over time on that water quality parameter? That would be pretty neat to see. Or, if we knew all sources in an area were accounted for, we could start then looking at other sources. If those weren't making a difference, let's go to the next one and so forth. So it might give a nice way to do a little self-reflection and a better understanding in a water body. But in general, I think what it's doing is really giving us a lot of information on how can we actually improve our current water quality sampling and how that's done. Is this, grab sample for fecal coliform? And granted, this is E. coli, not fecal coliform, it's different. But how does our current methodology of sampling benefit us? How can that be done better? It's very interesting that even though these are preliminary data, we're just still trying to figure them out and calibrate the machines themselves before we even have confidence in the data. But it is saying, all right, did routine sampling pick this stuff up? Or should we be doing it at a different time of day? Or how does this actually look when we analyze what we already have for routine fecal coliform sampling? I personally have now said, why don't we do a loading rate with fecal coliform sampling? 200 grab in this much water is different than a 200 grab in this much water for fecal coliform. And maybe this methodology is going to allow for that fluctuation that a lot of you notice in your local creeks. That is it fair when there's just this much water and they're getting samples out there versus I have 2 feet flow another time of year? Why is the same value of both of those seen the same? It shouldn't have the same weight. They should be different. So that's just a little bit of an example of the benefits of doing kind of exploratory projects like this, particularly with water quality, that it can provide data, yes, but more importantly to me, it provides better questions for us to look at and answer, and a reflection on our current activities that are being conducted within our water sampling group. So it's been a really, I think, a positive project so far, and some really interesting things coming out of there. Another thing that's going to come, and this kind of relates to your next talk here in a minute, is that along with this is that we want to do what's called a methods comparison study. So as you know, there's fecal coliform sampling going on right now. Other areas of the country do E. coli, not fecal coliform. And now we've got this new DNA methodology that's coming out. There's, Kent will talk about this, so I don't have to go into much, but there's various ways to even look at DNA methods and what's the value does that bring. So along with this, we proposed, hey, let's just compare, let's get one big water sample and compare all these things across the board and see which one has the best results and value for us and for you as farmers if you wanted to do some self-analysis and self-reflection on this stuff. So we want to look at 3 different ways to look at E. coli with that ZAPS monitor, and then there's just 2 other laboratory methods. One is the quote standard method, one is a lot quicker or simpler method that laboratories can do, and same with the fecal coliform, and then 2 different styles of DNA method. One that Kent's going to talk about, and the other one is a very similar kind of method, but just looks at DNA in a different way. There's many different ways to look at it. And then to say, all right, if we wanted to improve our water quality sampling, we're taking those samples anyway out there, how can we do them in a way that's going to have the most value for everybody to really help us understand what's happening out there and what's the best balanced sample or combination of samples to better understand sources or timing of things or significance of what we see. And so that's what we're trying to do here with comparing all these various things. And this is a study that we're still putting together and writing up all of our quality assurance plans and all this other stuff you have to do in the background of research that isn't very exciting, but ensures that you have a very good project that everyone can feel confident about that data. And so we're hoping to get started here in the next couple months to start collecting that data. So we have it over a year, right? So we can look at, yeah, just because you got a high fecal in February and you got a high fecal in June, how do we differentiate those two? Why was one higher? Why are they both high if we may have different sources and so on? So we're hoping we can start to tease some of that stuff out, because I know those are the questions you guys have all the time, and they're great questions, and they deserve answers. And they're not always easy to get, but we're trying slowly but surely with some of these different studies. And yes, it'll take a whole year. Hopefully this time next year I'll be able to present results of that back to you. These things also take a little bit of time, but the value definitely outweighs, I think, the patience when we can get these things together. And then some other projects and notes, this is tiny text, but I just want you guys to know, without having to read all these, we are doing a ton of different projects and practices and little projects and big research projects all the time to try to answer all the questions that you guys bring forth. And I love when you guys bring forth questions and say like, well, what about this? And why do I have to do this? And what in the world does this do? Those are great. That gives me the idea of like, if they're asking, I bet there's 10 other people, and I never thought of that. That's a great question. Let's design a project to answer it. So that's what I do, and that's what our team of research scientists in the Whatcom Conservation District does, and partners with others to do, to get this stuff to you. So we've done, a lot of work. Obviously, my interest and passion is in manure. I don't know where that ever happened. I think my parents think somewhere along the way I went wrong, like manure. But it's a fascinating topic, and look at how many people in the room actually care about it and see it as one of the most important things, either that you produce, that you work within, that you use, or that you value. It's pretty critical. So I appreciate that we're able to bring all this information to you in these broad research categories and groups. So before I turn it over to Kent, who is our next speaker, who's going to talk about the DNA work, any questions on that ZAPS project or any other upcoming research or research ideas that you want to ask about right now? In fact, right at lunch, we were talking about fecal coliform survivability. Yes, that is actually the next study I want to do, because it's a question everyone has. Well, if I apply manure in December versus June, how long is it before that fecal coliform is dead and I'm going to have a problem in my runoff? I have no idea. No one really does. It hasn't been done. We need to do that kind of work. So that's, those are the types of things that are great for me to hear from you guys to know that. So, any questions?